AI. There's David and Valerio Mioli with us today. And I suppose that today we're talking about deployment, which is going to be quite an interesting topic. Everybody needs deployment. So everybody should be interested in listening to you, David.
Yeah, absolutely. Today we are gonna show how to deploy the machine learning model we trained last week. And actually, we have multiple options. So usually, when you have to deploy a model, you have to decide where to deploy it, and obviously, different options have different properties and limitations and so on. Today, we are gonna go for the AWS Lambda functions. There are other options that maybe, we can talk about them another day. Like maybe SageMaker, for example, or AWS Batch can be valuable options. But yeah, I think when the model is pretty light, we should always go serverless. So Lambda is the way to go.
Okay, and would you put SageMaker into the serverless bucket or not?
No, because SageMaker create basically in EC2 instance, so it's not serverless.
Okay, so the first, if we have to, guide our audience in selecting what is the most appropriate deployment strategy, the first decision that they have to take is serverless or managed, right?
Yeah.
And what are the advantages and disadvantages?
I think it usually depend on the use you want to do of your function, of your application, and the frequency of the use, especially because all the serverless services have a significant time of initialization.
And this is a big disadvantage, right?
Yeah. So if you want a responsive application, or if you have to do a lot of calls, concurrent calls, I think that you should allocate like an EC2 instance for your service.
Okay. And then what are the other important variables that we have to take into account when we're deploying?
Absolutely. The model size, because as we will see, Lambda has huge limitations in terms of storage and memory.
Yeah.
And the performance, if you need specific performance in time, so if you want to be very efficient in time.
I think also if you need GPU or not, because I don't think you can use GPU on Lambda. Oh yeah.
Right? You can't.
So computation and memory, it's something related to the size of the model, right? The memory.
Yeah.
Okay, memory, startup time, computation. What else do we have to take into account?
Can a Lambda function be parallelized? I mean, can you run different instances of the same Lambda function at the same time?
Yeah.
Okay, so this is not, and it's I mean, it's automatically, the parallelization is automatically managed by Amazon, or you have to manage it?
No, it's automatically managed.
Okay, so if we are wrapping up this first part of the video by discussing the two alternatives, which is serverless versus managed, and we were evaluating these two options based on these three parameters, where would you put the API face? So API face is, is probably here. If your model size is big, you go to managed.
Yeah,
Right?
sorry, we didn't mention an important factor, that is the price, obviously.
Price, exactly. Price, okay. But the price is then a function of multiple.
Yeah, the price depends on how many requests you have per day.
Yeah, for the serverless, yeah. For the managed, no. You pay.
No.
You basically pay the computation time, right? So in the serverless, it's just only the time that you use the service. For EC2 instances, it's always.
There is a cap for a day, but at least if you use EC2 instance, you can't spend more than a given amount per day.
Okay. So serverless versus managed. Okay, if you have a lot of calls, which one do we pick?
Managed.
Managed, yeah.
Okay. If the model is very big,
Managed.
Well, you could go for AWS batch. That is a serverless,
which is a kind of intermediate.
No, actually, AWS batch. Yeah, it's in the middle, because it every time you submit a request creates a EC2 instance. But when the request is done, the EC2 instance is terminated. So again, here you are paying only for the specific processing time. So it's something that is in the middle.
Gotcha. Okay. So we put it in here, AWS batch. It's a third option. But let's say that we stick with this.
And also then at AWS batch requires also to build some API in front of it. I mean, I would skip for the moment it.
Complicated. So let's say that if the size, if the model size is small, okay, and we have few calls, what shall we use?
Serverless.
Okay, so in this case, so if we have very few calls, small model size, we go to serverless, right? If we have latency issues, so if we want to be very quick, what do we use?
Managed.
Great.
I imagine, no? I don't know how much is how much does it take starting a Lambda function, but I think it's slower than using an already started machine.
Yeah.
And if we don't have
initialization time, yeah.
Let's say that we don't have problems with the startup time. If we have a very small computation, model size is medium. So model size is medium, and not a lot of, we don't need a GPU.
Maybe serverless, if the model fits in the Lambda.
And if the model doesn't fit, Davide, do we have an option? Can we convert?
Yeah, there is SageMaker, that is basically an EC2 instance. So.
Okay, so SageMaker, we put it into the managed bucket, but you're saying no, actually, with SageMaker, we can spin an AWS instance, and then what's happening? Is it dealt with as a Lambda or not?
No, it's an EC2 instance, basically.
Always on.
Yeah.
Okay, so this doesn't help, right? So we need to go serverless if it's very infrequent.
Yeah.
All right. Okay. Well, this is. I think we, as usual, I kind of exploded the first part of these conversations on this overview, broad overviews. Let's get into the nitty-gritty details of the matter. And Davide, if you want to share your screen so that we can check out how. Okay.
Okay, so the Lambda architecture. Can you see my screen? Yeah.
Coming up. Yeah.
Yeah. Okay. So the basic architecture is something like that. So the service that we are going to use is AWS Lambda, and we want to. So Lambda is a serverless service. So the computation will be the Lambda will be triggered only when a specific event occurs. So in this case, we're gonna trigger the Lambda whenever there is an API call. And to handle these API calls, we are gonna use the Amazon API gateway that will handle everything and will trigger the Lambda directly. So the ultimate goal of this Lambda is to run the object detection model we trained last week.
Yep.
And so what should be the pipeline? We obviously have to send an image to the Lambda. The Lambda will feed the image into the model.
Mm-hmm.
And we are gonna gather the results and send back the results to the API. Okay.
Yeah. Any questions or comments, Valerio? Or clear? I think it is.
Yeah, it's pretty clear. Maybe we should highlight that the Lambda, when it's triggered, downloads the model and the image from some sites, because they can't be, or for example, the image can't be posted to the Lambda, I imagine. Into the request, for example.
Yeah, I don't think it's possible to send the image to the API call. So,
okay.
So you have to insert the URL of the image as a parameter of the API call, right?
Yeah. So in some way we have to first upload the image somewhere.
Yeah.
Get the URL and input it in the lab.
So
and
what about the implications on startup time if this image is very big?
Well, I think it will. The bigger the image, the longer the time for the Lambda to upload it.
Yeah, but I mean, in practical terms, Davide, did you experience any problems with this? Like, is it?
No, I don't think that the biggest bottleneck is in the downloading of the image, because as you can see here, there is another thing that will be downloaded on the fly. That is the machine learning model, so the parameters of the model, and they are really bigger than the image.
Okay.
And we download the model parameters on the fly because, as we said before, Lambda has huge limitations. Some of them are listed here.
Yeah.
So when you create the Lambda, as we will see later, you cannot create a package that is bigger than 250 megabytes. So if the model size is too big, you cannot store the model inside this package. You have to download the model parameters on the fly.
On the flies from a different from a third-party file.
Yeah, for example, from S3.
Okay.
And there are other limitations. For example, the memory capacity. I think, yeah, as you can see here, it cannot be bigger than 3,000 megabytes. And there is another limitation, big limitation, that is the computation time. It is 5 minutes. And yeah, the storage is only 500 megabytes, and you can only store files from in the temporary folder.
Is it fair to say that this Lambda function was not conceived and designed for machine learning applications? Because the way if you look at these parameters, it makes a lot of sense to use. It doesn't make any sense to even think about using Lambda for machine learning applications, right? Very little memory, very poor performance, maximum execution time. So this is not made for AI and machine learning. What do you think, guys?
Yes, absolutely. Most of the AI models are much bigger than the maximum size here, and also we can't use GPU. So yeah, definitely the answer is definitely no. Lambda was not invented for.
So, but what is the upside? What are the benefits, David? I mean, if we manage to squeeze a model into Lambda, what are the
The benefits are obviously in the simplicity on how you can deploy model and the service, and obviously the price, because it's very cheap.
Okay, very good.
So,
and in terms of easiness, ease to deploy, can you be a little bit more specific?
yeah, I have prepared a document here.
Mm-hmm.
We can very quickly describe how to deploy a dummy Lambda function. So to deploy a Lambda function, one of the easiest way is to a library called Zappa.
Uh-huh.
So to deploy the Lambda function, it requires mainly 3 files. So the app.py, that is the file where you describe the Flask application. That is going to be your API, right? So the endpoints, the methods to trigger the Lambda, and so on. The requirements where you list all the libraries and dependency that you need in your code, and the settings of the Lambda. So, for example, this is an example of the app. So this is a very basic app. So just return hello. So you create the Flask application. You define the methods with which you want to call the API, and the endpoint name. Here you can do all your operations. For example, you can run your model and so on. And then you return the results in the form of a JSON file. Then you have your requirements text file, where you list all your libraries, and the settings, where you describe all the properties of your Lambda. So the entry point of the Lambda, so the application that we defined before, the region where to deploy the Lambda, the project name, the runtime. So we're going to use Python. And the bucket where to store the Lambda code, and the memory size, and other features.
I would ask you some details, David, about keep warm.
As we said before, there is a startup time for Lambda, because after an undefinite time, the Lambda will be terminated, and so the startup time, you have to wait the startup time to reuse the Lambda. So this keep warm parameter make like dummy calls to the Lambda every now and then to keep it warm, so that you basically you are able to bypass the startup time.
Yes, but do you pay for those automatic calls, right?
Yeah, you pay, but
Okay.
they are like dummy calls, so that the computation time is very short.
So basically, when these dummy calls are submitted, the real code of the Lambda won't be executed.
Yeah,
But it's
exactly.
just a way to avoid
Yeah.
that. Okay, got it. Okay.
So just to be clear, this is important because if we want to, one of the parameters that we listed as key when it comes to deciding whether or not to go for serverless is startup time, right?
Yeah.
And with this trick, we are able to reduce that startup time to zero, almost zero.
Yeah, I think something near zero. Yeah.
And we do this by periodically
Trigger the Lambda. Yeah.
triggering the Lambda. And this is something that Lambda AWS does for us. Is it a parameter? What is it? Is it a parameter in AWS?
I'm not sure. I think that Zappa handles this parameter. So I think that under the hood there is like a rule with which Zappa will trigger the Lambda every 5 minutes, something like that.
Gotcha. Well, this is very important though. This is how do you set this? It's timeout. What is it? No, keep warm. Okay, it's that
warm, yeah.
Keep warm. So if you're using Zappa, you turn that keep warm parameter to true, and then you get these periodical calls that reduce the startup time. Terrific.
Yeah. Obviously, I think that this will impact the price, how much you pay, but I think it's not that much. So yeah, it's an option.
Awesome.
Okay, so once you have all these files, so you have your app, your requirements, your settings, you can deploy your Lambda. So you have to create a virtual Python environment. You have to activate the environment, install all the requirements, and then you can just run Zappa deploy to deploy your Lambda.
Mm-hmm.
Obviously, this is a very basic Lambda. We don't do any kind of computation. For example, in the Lambda that I deployed for the object detection model, I had to obviously run the model inside the Lambda. So as you can see, my app is quite more complicated. So, for example, in this app that has the same structure of the ones seen before, we have different stages. So, for example, here we download the image from the URL given from the client of the API. Here we download the model from S3.
Okay.
And here we just run the model.
Question. Which means that every time we invoke this Lambda, we have to download this model file, right?
Yeah.
This additional price. Because every time you download something to S3, you pay. I mean, it's very very low price, but if you do it, I don't know, n times per day, this might impact at the end of the month.
That's a really good point, and we're going to take notes. So is there a way we can avoid this? Is there a way we can preload the model from the outside, the Lambda? Like,
Well, maybe you can put your model on Dropbox and we get it every time from there.
Yeah, but you know that the interaction between an AWS service and S3 is very quick. So
yeah, of course.
you will not have the same download time of.
Yeah.
Are we sure that we're paying if you're transferring the model from S3 within the same region? Maybe we don't. We need to check this, but yeah, there is no way we can load this thing once at the beginning when we're starting.
No, it's not possible.
All right, let's go ahead. So there's a lot.
As I was saying, we have to run this model. So, for example, we trained the object detection model with Torch, with PyTorch, but the PyTorch library is too big to fit into the Lambda. So we have to, find an alternative. The alternative here is ONNX. That is a standard, let's say, machine learning schema for machine learning models. So we have to first convert the PyTorch model into an ONNX model format. And at this point, we can use the ONNX runtime library that is much lighter than PyTorch to load the model and run the model on the image.
Cool.
Okay, so for example, here we can see the API in action. So as you can see here, we have simple GET request. We have the base URL of the API.
How do you get how do you get the base URL?
Yeah, the base URL is printed when you deploy the Lambda, and then you can see it on the API gateway service on the AWS console. Okay, and so we have the base URL here, we have the endpoint name, and we have our parameter, that is the URL of the image that we want to detect. So we just run the code, and we have our detections.
Awesome. Well, it's pretty much self-explanatory. We started a month ago with an idea, which was taking an image. Do you have that image available? Maybe not. Doesn't matter. So it's an image of a text. We want to detect.
You can copy and paste the URL on the browser.
Yeah, we take this image. We want to detect bounding boxes of. We want to detect those highlights. Okay. What we did was to come up with a data set. We labeled the data set. We then trained the model, an object detection model. And today we took that model, we deployed it into a Lambda function, and we have an API. Amazing. Now, next week, we're going to look at how we can use this API into a mobile phone so that we can look at the whole life cycle from idea to productization. How good is that?
Cool. Yeah, terrific.
Guys, thanks a lot. It's late. It's Friday. So let's say goodbye to our audience. And
bye, guys.
We'll see you next week. In the meantime, please hit that like button, hit that follow button, hit that subscribe button, whatever platform you're watching us in. It's really important to us. And thank you very much for watching.
Bye, guys.